Hi, welcome to the video on area of regular polygons, and welcome back. So let's get started. Now, to find the area of a regular polygon, there's several steps that we need to go through, and sometimes we're given some of it, and sometimes we're not. So I'm going to treat it the same way in every single problem. And I have like these series of steps that we're going to follow. To find theta, which is the angle of the triangle that we're going to create, to find the apothem using trig, that's the first step. And of course, these regular polygons, this is a must. In order to use any of these steps, we have to have the problem to be regular and a polygon. So it's got to be a closed shape, it's got to have straight sides, it has to be, all of the sides are the same length, and all of the angles are the same measure. So it has to have all of those things before we even start. All right, so let's have an example and show you what I'm talking about. So here is an equilateral triangle. So it's given in the problem. I'm telling you that it is equilateral. So a triangle is a polygon, and it's equilateral, which means that it's equally angular. So we have an equilateral, equiangular, aka regular triangle. So theta, there's my little symbol for theta down here. Theta is the angle in the little triangle here that we are going to create to find this right here. It goes from the very center of the shape perpendicular to a base. That's our apothem. So that's what we're going to be solving for, to get that apothem, because that is in our formula, the itty bitty lowercase a. The capital P here stands for the perimeter of our shape, and we're going to need that to be able to calculate our area. So our area is equal to half of the apothem times the perimeter. And notice this is any polygon. So whether it's a 10-sided shape, like a decagon, or a 5-sided shape, like a pentagon, or this one here, this triangle, we use the same formula. All right, so we will go on to our first step here of finding theta. The first thing, again, to find theta, we're going to go back to something that we learned, hopefully learned, in the very first semester, very first 9 weeks. And that's that any polygon has a formula for the sum of all of its angles. And that is equal to, let me find something to write with here. There we go. That formula is n minus 2 times 180. And that's the sum of all of the three, well, in this case, there's 3 angles. But what I want more importantly is just one whole angle. So I want to divide that by n, and this, since it is regular, I'm able to follow and use this formula. Does this seem familiar to you? Hopefully it does. N is the number of sides. It's always subtracted by 2, and then you multiply that by 180. And then you divide that with n to get the whole entire angle. Theta is always half of this number. All right, so let's first find this in. So we're going to, since this is a 3-sided shape, we have 3 minus 2 times 180 divided by 3. Well, 3 minus 2 is just 1. 1 times 180 is just 180. So I'm really just doing, in my calculator, 180 divided by 3, which happens to be 60. Now, 60 degrees, again, is the whole entire angle here. That whole angle is 60. That means theta is half of that, 30. So theta being 30 degrees, that's my first step. All right, now hopefully you see that there's a triangle here. It happens to be right because again, the apothem must be perpendicular to a side. So there's my little apothem here. That's my little A. And I have a 30-degree. And I really don't have the length of this yet, but I do want to mention that this whole entire side is 14. From the apothem, right, from where the apothem intersects here, this portion of the side and this portion of the side, that apothem also touches the midpoint of a side. So therefore, I take the whole entire side and divide it with 2 to find this portion of the triangle that will help me solve for my apothem. All right, so now I'm going to use trig, or you can use your 30, 60, 90 rules. If you have a triangle, it will come out to theta being 30. But if you don't remember those, we'll go through them either way. We'll use trig, because trig is what we're going to use for all of them. So I want to use trig and keep with the same method, regardless of which shape we have, whether it's a pentagon or a decagon or a triangle. I want to use the same method. All right, so opposite over adjacent. So this is my opposite, this is my adjacent. And opposite over adjacent, as you may recall, is your tangent. So I'm going to set up an equation to solve for my opposite by writing an equation. My tangent of 30 degrees is equal to the opposite, which is alpha, or my little apothem here, my A, over the adjacent, which is 7. Now, as you may recall, my number is on the denominator, so I'm going to be multiplying by 7. That goes in the calculator first, and I then multiply it by tangent of 30. Please make sure that your mode is in degrees, otherwise you get some weird number. So 7 times the tangent of 30 gets me my apothem as 4.041 if I were rounding to the thousandths place. Okay, so that tells us what my apothem is. Now I'm going to figure out what my side length is and to help me figure out perimeter, and then I'm able to solve for the area. All right, so my area, let's use a different color here. My area is equal to 1/2 of my apothem. I'm going to write that in, 0.041. And that's multiplied by the perimeter. So 14 plus 14 plus 14. If you need some help, you certainly can use the calculator. That is 42. Okay, so as you see it here is how I'm going to type it in my calculator. Or you could just take half of 42 in your head and multiply that by that. It really doesn't matter. You should get the same answer regardless of which one you do first, whether it's the half, the 4.041, or the 42. And when you get all of that together, let me just multiply that all together. In my calculator, we get an answer of 84.861. I want to check my time here. I am on, yeah, I'm going to pause here and come back for the second part of our video in just a bit.